Okay, so let's talk about electric fields. Remember, the whole thing with electric fields is that if you have positively charged particles, the electric field points away from the positively charged particle. If you have negatively charged, everything points towards it. This is kind of the main rule. And then the other thing is, remember that this still talks about Coulomb's law, which Coulomb's law is K times the first charge times the second charge divided by the distance squared. So it's this kind of exponential change if the distance changes. All right, we want to know which diagram represents the electric field between two small electrically charged spheres. So positives always, everything always points away from positives. So this one is showing a positive, which is being attracted to a positive. Not going to happen. This one shows a negative pointing away, which is good because the forces would go away from the negative towards the positive there. But remember that with a positive charge, you're going to get charges this way, but everything goes towards a negative. Okay, and so it would be the positives would be approaching the negatives, but it wouldn't be the negatives approaching the positives, so that doesn't work. In this one, you have negatives leaving, which would go towards the negative, and you have positive leaving, that would work, but there's no attraction between positive and negative. And in this one, you have positive, which is leaving, which it should be on both sides, but they're also repelled from each other, so this is the best answer. This one here is, remember that our equation for electric fields is E divided by F over Q, so force divided by charge. Now remember, this means that there's a direct relationship between electric field and electric force. And since force is affected exponentially by the distance in between, then electric fields are affected exponentially by the distance in between. So I want something that shows exponential growth. So without even looking at any of these other three, I can tell you this has to be the answer because you're going to get exponential growth. Now, as you increase the distance, the electric field should get smaller, which makes sense because the farther you get away from something, the less force the two objects can feel on each other. This one is negative, but it's not exponential, so it has to be 4. A diagram below represents an electron within an electric field between two parallel plates that are charged with a potential difference of 40 volts. If the magnitude of the electric force on the electrons is 2 times 10 to the negative 15 newtons, the magnitude of the electric field strength between the charged plates is, remember this is E is equal to F, which is newtons, divided by Q, which is coulombs. So I have newtons. 2 times 10 to the negative 15 newtons. It's an electron. We know the fundamental charge is 1.6 times 10 to the negative 19 coulombs. And they gave us the equation, newtons divided by coulombs. So 2 e to the 1.5 negative, 2 e to the 1.5 negative divided by 1.6 e to the 1.9 negative, 1.25 times 10 to the 4th, newtons divided by coulombs. Two oppositely charged parallel metal plates, 1 centimeter apart, exert a force with a magnitude of 3.6 times 10 to the negative 15 newtons on an electron. Calculate the magnitude of the electric field strength. Well, newtons divided by coulombs, that's what we already learned was electric field strength. So 3.60 times 10 to the negative 15 newtons. 1.6 times 10 to the negative 19 newtons. Coulombs. This is newtons divided by coulombs, so we're set with that. 3.6 e to the 1.5 negative divided by 1.6 e to the 1.9 negative. 2.25 times 10 to the negative 4, positive 4, never mind, newtons over coulombs. All right, last one. An electron is located in the electric field between two parallel metal plates. There's my electron. If the charge is attracted to plate A, then plate A is charged. If a negative is attracted to A, then A has to be positive. Okay, now the next thing is we have two that are positive. so it's got to be 1 or 2. The electric field is directed towards plate A, or from plate A towards B, or from B towards A. Well, the rule is if it's positive, everything goes away from it. If it's negative, everything goes towards it. So plate A has to be, because it's positive, the electric field has to be pushing away from it. So this is our answer.